Okay, now that we know how to assign oxidation numbers, let's apply this to analyzing redox reactions. And when we analyze these, we're going to assign the roles of oxidation and reduction, and also the roles of oxidizing agent and reducing agent. And I want to go over these terms because they are a little bit confusing. It makes more sense if you understand why exactly we use these terms, but I want to go over this. So, an oxidizing agent is something that causes oxidation. So it causes something else to be oxidized. Since it's causing something else to be oxidized, it itself is undergoing reduction. So the oxidizing agent is whatever gets reduced. Hence the fact why I want to go over this, because it's a little bit confusing. So the oxidizing agent is gaining electrons. It's undergoing reduction because as it gains negatively charged electrons, its oxidation number reduces, becomes more negative, and the oxidation number therefore decreases or becomes more negative, however you want to put that. The reducing agent is the opposite, so it causes reduction, hence reducing agent, causes something else to be reduced. Since it's causing something else to be reduced, so something else to gain electrons, it is losing electrons itself, and so it undergoes oxidation. And the oxidation number, therefore, becomes more positive or increases. So let's look at one of those equations from a few slides ago, where we have the oxidation of iron to form iron 3 oxide. Here, we're looking at the elements iron and oxygen and assigning oxidation numbers on both the reactant and the product side for each element. So iron starts off as a pure element with oxidation number 0, like any pure element. And in the compound iron 3 oxide, this consists of Fe3 plus ions and oxide 2 minus ions. And to balance the charges, we need Fe2O3. So, being a monoatomic ion, iron now has a plus 3 oxidation number. Now if we look at oxygen, oxygen starts off as O2 gas. That's a pure element, so it's going to have an oxidation number of 0, like any uncharged pure element. And in the compound Fe2O3, these are oxide ions, so those are monoatomic ions, and hence the oxidation number is just the same as the charge, -2. So if we look at oxygen, highlighted here in red, this starts off at an oxidation number of 0 and goes down to -2. So the oxidation number decreases and is therefore reduced. So oxygen undergoes reduction, and since it's undergoing reduction, it causes iron to be oxidized, and so the oxidizing agent here is oxygen, O2, is our oxidizing agent. Conversely, if we look at iron, that started off with an oxidation number of 0 as an uncharged pure element, and its oxidation number increased to +3, became more positive. So iron undergoes oxidation. Since it undergoes oxidation and is causing oxygen to be reduced, iron is the reducing agent here. So Fe solid is the reducing agent. Now we can go back and analyze the reduction of iron 3 oxide with carbon to form iron and carbon dioxide. This is where iron gets reduced, so let's go through and assign oxidation numbers. We've highlighted iron in red and carbon in blue. Iron starts off with a +3 oxidation state and ends up at 0 because we're starting off with monoatomic iron ions in Fe2O3, so that consists of Fe3 plus and oxide O2 minus ions, and we end up with iron as a pure element, so 0. The oxidation number decreases, becomes more negative, so this undergoes reduction, so our oxidizing agent is Fe2O3, specifically the iron ions present in that compound are the oxidizing agent. Carbon starts off as a pure element with oxidation number 0, and it eventually becomes part of carbon dioxide, where it has an oxidation number of positive 4. We can tell it's positive 4 because carbon dioxide is charge neutral, so all the oxidation numbers need to add up to 0. Each of these oxygens, being part of a compound, is going to have an oxidation number of -2. So if we have one carbon and 2 oxygens, which are each -2, to get all the oxidation numbers to add up to 0, this has to have an oxidation number for carbon of positive 4. That means that carbon's oxidation number, as the reaction progresses, goes from 0 to positive 4. So it increases. So carbon undergoes oxidation. Hence, carbon is our reducing agent. Specifically, solid carbon is the reducing agent. Now, it's worth pointing out, as I will here, that in a redox reaction, not every element needs to change oxidation numbers. As long as one element changes oxidation numbers and another also changes oxidation numbers, we can have a third element where that doesn't change. So to point that out, we're going to look at oxygen. We assigned oxidation numbers to oxygen in Fe2O3 on the previous slide, so hopefully you believe me when I say that it has an oxidation number of -2 here. And I just said that going by the rules for oxygen and covalent compounds, in CO2, oxygen should also have an oxidation number of -2. So oxygen is present in this reaction, and it does have an oxidation number assigned to it of -2, but it doesn't change as the reaction progresses. So oxygen itself does not get oxidized or reduced, and likewise, it's not going to be an oxidizing agent or a reducing agent. But that's fine, because as long as we have other elements that fill those roles, we can have a third, fourth, and so on element that don't undergo oxidation or reduction in a redox reaction. We only need one element to be reduced, another element to be oxidized.